Hello, everybody, and welcome to UXDX Online. Today, we're kicking off our design process series, and we've another two great speakers for you this evening. But before we jump into the talks, which I know is the main reason why you're here to learn and figure out ways that you can improve your ways of working, I just wanted to give a very quick introduction to what it is that we do at UXDX and why we are running these sessions. So at UXDX, our mission is to help companies shift from building software in projects to empowered autonomous product teams. And the reason why that's our mission is because we believe it's a more efficient, effective, and sustainable way of working. And why I say that is because when you're working in a project, you kind of bring a team together, disband the team, then go across, bring another team together, disband them. And that makes sense when you don't have a lot of changes happening in any particular given area that you need people to be able to move around. But today, in today's context, what a lot of people are experiencing is that there's almost continuous change all over the place. And what's happened in a lot of companies is they've gone from running infrequent projects to running 80, 100 projects in parallel at any given time. So while we're kind of keen to say there's no one size fits all, that project structure is the best structure in a low change environment, because then you have that flexibility of moving people around to where the change is needed. But if you're in a high change environment, that's where we believe this cross-functional product team is a more effective and efficient way of working. Now, it's easy to say, okay, we'll just shift from projects to products. But actually, that changes quite a lot for both the people kind of signing off the projects as well as the people working on them. So in a traditional project, you have your specialists, and you can have up to maybe 20 different specialists that might be involved, from architects to kind of your upfront interaction design, product design. Then you're looking at your researchers, you're looking at your kind of different front end, back end, data specialists, QA specialists. I think I counted over 20 on one project that I worked on once. But if you move to a product team where there's a maximum of kind of maximum 8 or 9 people, how do you manage that? And the way you approach it is you look at what's known as T-shaped skills. So instead of having just a pure speciality in one area, you have a broad understanding of multiple different parts of the product delivery lifecycle. And what that means is that people can move in and out of roles a bit more flexibly, and they can take on some of those roles that were previously done by specialists. So that's why at UXDX, we invite product, UX, design, and dev to all of our sessions, because we want to help people build that cross-functional skill set so that they can become more empowered members of product teams. The other thing that we ask is that we always say, can you give some examples with what you're sharing? Because theory is great, but it's always the challenges when you try to put that into practice. So it's always great to kind of see what are the pitfalls, what are the challenges that will likely occur when you start putting this into practice. And if you have any questions, that's what we're here for today. So our speakers today, they'll be more than happy to answer your questions. And please do ask them, and we'll try to get through as many as we can today. But if we do run out of time, we do have the UXDX community Slack, which has an Ask the Speakers channel, where we'll put any questions that we don't have time to get through today. We'll put them in there and we'll ask the speakers to answer them. So without further ado, I want to hand you over to Sebastian and Claus, who will be talking about experimentation for product managers, a quick guide. So welcome, Sebastian and Claus.
Yeah, thanks for the introduction. So welcome everybody to our talk about experimentation for product managers, a quick guide. And first of all, we would like to introduce ourselves. So my name is Sebastian. I'm a business agility and product coach at Accenture Business Agility, which is a unit within the large Accenture universe that focuses on large-scale agile transformations. And prior to that, I've been a product manager and product owner for different products, mainly in the field of e-commerce, but also in automotive, for example, PO for a car configurator team, and also for different apps. My personal fields of interest are especially product discovery, product vision and strategy, and agility at scale. And with that, over to you, Claus.
Thanks, Sebastian. So Hi everyone, my name's Claus. I'm, as well as Sebastian, part of Accenture Business Agility. I'm as well a business agility and product coach, as Sebastian also stated. My special areas of expertise and interests are definitely in the area of learning and enablement, as well as agile product development and delivery. And I'm very happy to have this talk with you today. And let's now directly jump into our first content slide, which actually is a quote which I brought to you by Eric Ries, the author of the Lean Startup. I guess most of you will know him or his book. And the quote states, "The only way to win is to learn faster than anyone else." And how this is connected to the topic of experimentation for product managers, we will now explore in the next few minutes and in the next few slides together. So if we're now looking at a product management in general, then we have to admit it's quite a complex thing to do. I've brought to you now the design thinking double diamond, which I'm sure you know. We're starting to discover, design, and go to develop and deliver, diverging and converging twice. And this is a good example to high levelly see like how much complexity there's actually within product management. Because if we're working in product management, we are always working with hypotheses. And whether we do this explicitly or implicitly doesn't matter. We do have a hypothesis at every single step during our product development. So, for example, if we're in the discovery, we might have the hypothesis that we are actually asking the right questions to the right people. And then if we are deciding for a problem to solve, well, we have the input from our discovery work, but there's still like underlying assumptions and the hypothesis that we are now actually trying to solve the right problem with what we are now picking and choosing, right? And then if we have come to a well-defined problem, and if we are now going into the solution area, if we're now putting in options to how could we solve that problem, then for every option on our plate, we have the underlying assumption that this is a good approach to solve the problem, right? Otherwise, we wouldn't pursue it. And then when we decide on the approach and we are actually going to deliver it, then there's still the underlying assumption and hypothesis that our solution will actually lead to the desired outcomes for us, for our users, for our customers. And now what makes product management such a complex art, I would say, is that it's not enough to be right at one point, to be right with one of your hypotheses, but actually for a successful product, you need to be right all the way through. Only if you're right all the way through, you will actually have a product that will make a difference. You will actually have a product that has the potential to be a successful product in the end. And of course, the sooner we learn that we are on the wrong way, the sooner we can adjust our course. And if we learn it too late, that our hypotheses have been wrong, then we are wasting not only money and time, but we are also wasting, or we are also endangering in doubt the trust that our users will give into us and our product. And this might lead to the ultimate failure of our product, as we've seen in many examples that I guess I've brought you a few of examples of products that have failed. So I guess you know a lot of them. So if you could click one more, yes, perfect. So I guess you know a lot of them, and it doesn't matter if we're now talking about Google Plus, or if we're talking about Amazon's Fire phones, or about the experiment of Facebook to come up with some proprietary desktop screens and personal computers on their own. All of those have failed, and they have not failed because of technological challenges, or they have not failed because the user didn't get it. They failed because there were assumptions and hypotheses made that have been falsified way too late in process. Way too late, we learned that this is just not gonna work. And there we were already down the line. We have already invested quite a lot, and the only thing that remained as the only viable solution now was pulling the plug and not wasting any more money on those products. Now, if we're jumping further, then of course we have to ask how can we avoid that happening to products that we are building? And the good answer is there's actually an easy recipe on how we can try to avoid that. And the recipe is learning efficiency, or the goal is learning efficiency. Now, it might look a little bit complicated on this picture, but let me guide you through it. So learning efficiency, we define as the result of having learning precision divided by the required time and required money that we have to invest. So in other words, like how much bang do we get for the buck, or like how much learning do we get for our invested time and money? And now learning precision in our connotation has a few different aspects to it. So there is the amount of learning, there's the relevancy of learning, and there's the precisiveness of learning. So do I learn enough? Do I learn the things that really will help me to decide if something is going in the right direction or not? And how accurate is what I've learned? So how much can I trust my learning actually? So this is the learning precision. And now if we're imagining how we want to increase learning efficiency, then we do have three variables. Pretty easy, right? So we do have, we could either increase learning precision, or we could try to decrease the time and money invested for our learning. All three variables, if handled correctly, will lead to a higher learning efficiency. Okay. Easier said than done. Now, if we're looking at a few steps, how we can actually achieve that, we would see that there's no rocket science behind that. It's actually pretty straightforward. So we've brought you a few steps that can help you to increase learning efficiency tremendously. And the first one is to work with written hypotheses. So write down what your hypotheses currently are. This, as I mentioned in the beginning, we always work with hypotheses in product development, but most of the time I observe that they are implicit. And there's a few dangers to having implicit hypotheses. Well, the first one is if you're having 3 or 4 or 5 people working on the same product and you have just implicit hypotheses, then who ensures that you're all thinking the same? Who ensures that you have all the same hypothesis that you want to follow and verify and actually lead to the same outcome that you want to have, right? The other thing is that if we don't make hypotheses explicit, we quickly forget through being nitty-gritty in the details every day. We kind of forget what we thought like 2 weeks ago, what would be important. So first thing, very easy, write down your hypotheses that are currently of the most importance of you to clarify. Second step would be using tools, methods, frameworks, whatever is handy to you, workshop formats, in order to test these hypotheses, verify or falsify them as quickly and inexpensively as possible. So choose from a variety of options that you have to address your hypothesis, to learn from them, and try to do it. Try to already choose for a quick and inexpensive way. And then now comes a very, very important next step, of course. Now you've written down your hypothesis, and you've tested your hypothesis. Now what you have to do is, of course correct based on your learnings. And what's important for me is to course correct on two perspectives. I think it's clear for everyone that you have to course correct basing on your underlying hypothesis. So if you're falsifying, if you come to the result that whatever your assumption was is that wrong, then great. You have to change that, and you have to think, what does that mean for your product? But what I would also recommend is to take a few moments and reflect on the method that you used. Now, if you're looking again at the left-hand side of the picture, think about, was the time and the money I had to put in, was this in a good relation to what I've learned from it? How accurate and how relevant is what I've learned with this method, with this tool? And think about if you either want to keep it or if you want to drop it. And if you want to keep it, then think about, is there any way how you can increase your learning precision or decrease the required cost if you're repeating that method again the next time. Now the next step would be to minimize the time that you require for those learning loops. So if you're doing this now constantly, and if you're reflecting both on your product hypothesis and your methods that you're using, then we will automatically come to a point where you're getting more used to the methods that you're using, and that you get more used to the complete process, and then you will reduce the time that you need, and you will shorten your learning loops, which is great because this will give you insights earlier, and insights earlier equal to money saved, right? And then the last step, very important, and this is the only difficult one, because the other ones are very straightforward, but this is the only difficult one. You have to hang on. It is a thing of discipline. To really keep on doing what you're doing, keep on the path of excelling your learning efficiency, and not drop it after 2 weeks or 3 weeks of trying out. Now, I've talked about that you have to just pick and choose from tools which you can use to test your hypothesis. And if you're now looking at our toolbox that we have, then we see this is not really a challenge. So it might be a challenge to decide which one you like more, but it's not a challenge to find suitable ways of testing your hypothesis, because there has been many people who have put a lot of thought into how can I test and validate assumptions. And I've put you some of the ones from my toolbox here on this slide. This is by all means not a complete list of possibilities, and we could probably exchange for hours on different formats on how we can learn and how we can test our assumptions in different states of our product development. But the important thing is, it's not about the tool that you're using or the method that you're using. It's more about like what fits to your context, to your stakeholders, and also to your preferences. And then keep it as an actual toolbox. Try to keep rust from your tools. Try to exchange broken tools for new ones that serve a purpose better, and try to hang on to the best tools that you already got in your toolbox, which you can use like every day you have to do your work. So now, if choosing or if getting to a method and tool is not the challenge, then there has to be another challenge with regards to that. And Sebastian will now talk to you about exactly the challenge that we see.
Exactly. And this challenge is about applying the methods we have correctly. So it's important to consider which hypothesis I want to test in which step of the product or product feature development. And here at the beginning, I'm at the point where I would like to understand the problems of my target audience in order to derive certain opportunities. And here I'm still very far away from developing actual code, and methods like problem interviews, for example, makes the most sense here. So this is really the point where I would like to understand a problem as precisely as possible, including the context of the problem. So in which situations does the problem occur, and how is the target group right now solving this problem by certain alternatives or manual workarounds they use. Accordingly, the effort here in this step is quite low. I only have to invite subjects of my target group and think of an interview script. And when we move on, in the second step, I want to verify that it's really worthwhile to solve a certain user problem. So here I can use methods from the previous slide, like jobs to be done, or I can create and analyze customer journeys. The effort here is already a bit higher because usually I produce first UX artifacts here. And now when we leave the problem space and move over into the solution space, so once we have verified the user problem, it's about testing alternative solutions. So one possibility here is to develop various clickable prototypes and test them against each other in, for example, user experience labs with test persons, maybe representatives from my defined personas. And again, the effort here is higher as I develop prototypes, and the more realistic, or as we say, the higher the fidelity of the prototypes, the higher the effort, of course. And then in the very last step, I only start producing actual code. So that means here I really develop a feature, and then I test the impact of that feature, for example, in an A/B test in my real product. So this is here what we mean with code-based experience. And when we summarize it, the goal is to carry out tests and experiments as early as possible with less effort. As we've seen in the formula, this increases our learning efficiency and provides us with relevant findings early on, which in case of doubt prevents me from producing expensive code for features that the customer does not use in the end. So here, if we start to test very early on our hypothesis, we have a good chance to save money and time that we've put in the that would put us in the wrong direction. And I've brought you along a concrete example of a product where I accompanied the team as a product coach. And at the time we had developed Aino. Aino was a lifestyle companion app for young people in Hamburg, so in the second biggest city in Germany. And the background was here that we had a German savings bank that lost more and more the connection to the younger target group and was now thinking of new ways on how to revitalize this connection and also learn more about the younger target group in order to later develop certain financial products, financial services, specifically addressing younger people. So when we started with the product development process, our initial hypothesis was young people often feel lost when starting out in a new city. So young people have just finished school, now moving out from home, most likely in a bigger city where they want to start studying or starting their first job. And we had the hypothesis that in this case, they often feel lost when starting out. What we did We recruited via Facebook representatives of our personas. So Facebook was quite easy to target by or to filter by specific age and also by city Hamburg. We invited them to our office and conducted problem solution interviews to see if the prospects confirm our hypothesis, and we gave us a certain threshold number, and this number was reached. So for us, we validated that we have a problem solution fit here. And then in the second step, we refined our hypothesis further. So we made it more specific what the young people are looking for. And we said they are looking for going out tips, perks, and career advice. And again, here we conducted target group interviews in our office, and based on those interviews, we wanted to derive so-called jobs to be done. So what jobs is this target group trying to accomplish? And then we matched the jobs with the topics in our hypothesis and confirmed that those jobs match those topics. So again, we proved the problem to be worthwhile to continue to solve further. So now we leave the problem space and move over to the solution space, where we had several solution ideas, but our hypothesis and the most promising one for us was developing a lifestyle companion app that gives young people a jumpstart in their new stage of life. And what we did here, we created two versions of a clickable prototype. One at this point in time, it was some years ago, with a quite innovative chatbot user interface, and one version with a classical navigation. Within our product team, we were very much convinced that, especially for a younger target group, the innovative chatbot user interface would perform better. But as always, the new user knows it better. So the chatbot interface has failed. But even more important was that the results were still quite positive, as a large majority wanted the product in general, but just not with the chatbot user interface. The effort for testing this stage was much higher than in the problem space, because here we created high fidelity prototypes. And then in the very last step, we started to develop and launch a minimum viable product of this app. And our hypothesis was that young people regularly use the app to plan leisure activities. And in this hypothesis, we tested, we proved via in-app tracking, so tracking of retention, weekly usage metrics, we surveyed Net Promoter Score, and ran continuously cohort analysis. Of course, here the effort was the highest, as we developed several months in MVP here. And now when we have seen the example and reflect a little bit on the previous slides, I have to admit that experimental product development always reads so easy, but often we still let ourselves get distracted and fall into old patterns. And here's where it's important to understand a few anti-patterns or biases that we keep falling into, so we can recognize them and then discard them also immediately. And one is the so-called action bias. The action bias means we prefer to do something instead of doing nothing. Usually, but not always, because it often leads us to jump directly into the development of solutions. So we skip the problem space, directly jump into solution space, where we have seen in the previous slides that often testing hypotheses in the problem space requires much less effort and gives us very early if we should pursue a certain path or not. With the action bias, we skip often the problem space. Then we have the sunk cost fallacy, which means we find it hard to let go of things we have already invested time and or money in. Now, and this makes us reluctant to give up our direction and thus further increases sunk costs. So for example, we have launched a certain feature the feature, our users are not using this feature, and then we say, okay, I have another idea how to tweak this feature. We work on it the next sprint, still not working. We do another tweak, still not working, and we all know that we should have given up much earlier, and that would have saved us a lot of money and time for more valuable things. Third, we have the confirmation bias, which means we look for proof or evidence that confirms our opinions or assumptions. And this often leads us to develop in the wrong direction and burn money. So the result is quite similar to the sunk cost fallacy here. Then last but not least, we have incentivization, which means we do everything that leads to being rewarded materially or socially. And this does not always have to mean the best for the product or our customers. Let's take the example, we have a very strong stakeholder in our organization who has certain feature wishes, and we just accept them because the stakeholder has influence on our bonus payment at the end of the year. But those features might not be the ones that are most valuable to our customers. So we might get our bonus at the end of the year, but our product might be not successful as a result. And when we have a look on those anti-patterns, we see that the first three ones are more of human nature, whereas the last one is a structural problem that we often have in organizations and that we need to solve also on an organizational level. I'm showing you those anti-patterns because for me it's important that you as a product manager or a member of a product team are aware of those anti-patterns in order to be able to catch them when you fall into them and discard them immediately. So now we are slowly coming to the end of the presentation, and I would like to summarize on how to increase the learning efficiency. So we have mentioned it already, but it's about practicing. The more experience you gain in experimentation, the better you become. So you need to run through the process several times, start with a hypothesis, test the hypothesis, derive a certain action, and repeat. Second, we've shown you that there's an immense amount of methods available. You need to find your toolkit that suits best your context and your product team. Then find your experimentation process. So use simple experiments to verify assumptions before coding. So really take your time to analyze and experiment in the problem space before jumping into cost-intensive solution space. Then you need to create a culture of experimentation, like fail early and often, but celebrate lessons learned, not just successes. So when you learn early that a feature idea might not be worthwhile to pursue further, it's also a success because you have saved money and time early on. And when your context changes, you need to adapt your methods, toolkits, and process to the new context. So let go of methods that no longer fit to your environment. And last but not least, coaching. So when you're lucky and have experienced product leaders in your organization, use them as coaches, mentors, and trainers. They have a lot of experience where you can benefit from. Another good possibility is to create so-called communities of practices, for example, product management community of practice or product discovery community of practice, where you exchange with your peers or between different product teams, and you learn what worked well in one team, and you can try those things also in your team. So this is also a good possibility for exchange and also for creating a culture of experimentation. And last, we have brought you some further recommended readings. I think both books might be very, very popular here in the target audience. So Marty Kagan Empowered, which is about product leadership, and Teresa Torres Continuous Discovery Habits, which is more hands-on, let's say, product discovery manual. And I'm also regularly publishing product management articles on my Medium blog. So if you would like to follow it, you can scan the QR code above. And yeah, with that, we are finished with the presentation, and I think we're opening up for questions.
Great. Thank you very much, Sebastian and Claus. That was really interesting. I just find that one of the things that just popped straight into my head when you were saying, okay, we need to experiment quickly, we need to get short cycles. The very topical news right now is Twitter, and they're experimenting and they're doing it very quickly. So my question is there such a thing as too much experimentation, or is there a kind of a risk with experimentation and damage to the brand?
Well, if I may start, Sebastian. Of course, there's a risk associated with experimentation, but I would also say there are different levels of experimentation that you can run, as we've tried to cover in the different steps. For example, basically on the design thinking double diamond. And what I feel that Twitter is doing is like they're doing a lot of experiments in the deliver state without having verified the assumptions beforehand. Those are the very expensive experiments that we've talked about. So they're probably learning a lot right now, but at a great expense. And the expense might be too big. I don't know.
Yeah, I agree. I think going a little bit crazy, but I'm really interested to see. I think just 6 months, I don't think anybody knows right now. I think 12 months down the line, we'll have a better feel for whether it was the right call or not. And then there was one question on the chat came in from Sana, and she was asking about statistical significance comes up a lot in experimentation. So what's your opinion on that? Because you had in your slide the precision kind of variable. How precise do people need to be experimenting?
Sorry, I had a short lag in the last part of your question. Could you repeat your last sentence?
Sure. I was asking about statistical significance. So in your diagram, you had precision. So how precise do you need to be when you're running your experiments?
Yeah, that's a very good question, right? So this is something that I would say you also need to learn, because I think there's no one correct answer. So if it is a matter of life and death, then you better be pretty damn precise with what you're trying to validate or falsify. If it is a less impactful, then probably the cost, because cost and precision are not decoupled from each other, right? So you need to find the balance that is suitable for your context, and this is why we put an emphasis on those short learning loops. And on the two perspectives in the learning loops, not only use them to verify or falsify your product hypothesis and how to move on with that, but also to look at your process and to see, was this now accurate enough, and do I need more accuracy for this or similar questions in the future? Or would less accuracy also be fine for me if I could save some money or time when I do this, right? And this is the thing that I think is also very important, that you also constantly reflect on the methods and the process that you use in order to increase your learning efficiency, because those variables are not standalone, they influence each other. And so there's, I think, again, no one correct answer to how precise do you need to be. But you need to be very contextually aware of that, and this will differentiate even for the same product if you're having different questions at different stages of your product development.
Excellent. And I did like in Teresa Torres's book, she said you just need to get enough information to make it not the most important question, and then move on to the next question, and just keep kind of validating.
Yeah.
So, well, great. Those were the questions that were submitted in. So thank you very much. I really enjoyed that talk, and yeah, thank you for sharing your insights.
Thanks for inviting us.
Yes, thanks for having us.
Thank you. So that brings us to the end of our session today. But if you did like the session, we do host conferences around the world. We have one in the USA coming up in May, and we also have our EMEA conference taking place in Dublin in October. If you liked what you saw today, but want to see that at a much larger scale, then please do come along and join us. It's always a great few days in Dublin, where lots of learning, lots of great experiences, and meeting people from all around the world. But that brings us to an end today. So thank you very much for joining, and look forward to catching up with you again soon. Thank you very much. Goodbye.